So in this lesson, we want to look at the transformation of functions. And the first transformation that we want to look at is called a vertical translation or a vertical shift. This transformation has the form f of x plus p, where p can be negative or positive. Recall that f of x refers to the set of y values or output values. So under this transformation, we add p units to all our y's. We want to use this graph as an illustration. So basically, it's a graph of f of x, the function f of x, and it's a parabola with a turning point p at 1, negative 1. So under this transformation, any point on this graph, let's say xy, so a general point, will be mapped to a point x, y plus p. So our x's will remain the same, but we add p units to all our y's. Let's take a specific example. Let's say we have the transformation f of x plus 1. So each point on this graph, let's say x, y, will be mapped to the point x, y plus 1. So if we take the point P, the turning point, which is 1, negative 1, it will be mapped to a point P prime. Nothing happens to our x's, so 1. And then we add 1 to the y's, so negative 1, plus 1. And of course, this is the same as p prime, 1, 0. Let's take another point, 0, 0, the intercept or the x-intercept for this graph. It's also the y-intercept. So if we take the point 0, 0, it's going to be mapped to 0, then 0 plus 1, which is 1. If we take the other x-intercept, which is 2, 0, it's going to be mapped to the point 2, 0 plus 1. So 2, 1. And now we can basically plot a new graph for this transformation f of x plus 1 by using these points. So p prime 1, 0 will be over here. 0, 0 will become 0, 1, which is over here. And then 2, 0 becomes 2, 1. So 2, 1, which is here. And we can now draw a graph. And this blue graph will be the graph of f of x plus 1. So we can see that under the transformation f of x plus 1, the graph of f of x has shifted up 1 unit. So a vertical translation or shift of 1 unit up. Let's take the same example, but now with the transformation f of x minus 1. In this case, each point on the graph, xy, will be mapped to x, y minus 1. So once again, our x's remain the same, but we subtract 1 from our y values. So the turning point P, 1, negative 1, will be mapped to p prime, 1, negative 1 minus 1, so negative 2. The point 0, 0 will be mapped to 0, 0 minus 1, which is minus 1 or negative 1, and the point 2, 0. So 2, 0 will be mapped to 2, 0 minus 1, negative 1. We can now use these points to plot the graph of f of x minus 1. So the turning point will be 1, negative 2. Then we have 0, negative 1. And we have 2, negative 1. So 2, negative 1. You can draw the graph. And we can see that in this case, the graph of f of x under this transformation has shifted down 1 unit. So it shifted down 1 unit. Then the second transformation that we want to look at is called a horizontal translation. Now, this translation has the form f of x plus p. So note that we are adding p inside the brackets to the x here. And p can be negative or positive. Let's take this example. Here we have the graph of f of x. Once again, a parabola. And let's say we want to look at the transformation f of x plus 1. So what's important to note here, that this is a horizontal translation. So a horizontal translation or shift of 1 unit. Very important, to the left. So important to note here that when we add a number to the x inside the brackets, the shift will be to the left. So we can take a couple of points. Let's take the turning point of P here. So the turning point P, 1, negative 1, will be mapped to P prime. Now, as we said, it's a shift to the left. Although it says x plus 1 here, we're going to subtract 1 from the x's. So 1 minus 1, our y's remains the same, will remain the same. And of course, this is equal to P prime. 1 minus 1 is 0, and then negative 1. So it says x plus 1, but we subtract 1 from the x's. We can take another point, let's say 0, 0. It will be mapped to the point 0 minus 1, so negative 1, 0. Then the second intercept here, or x-intercept here, of 2, 0, will be mapped to 2 minus 1, so 1, so 2 minus 1, and 0. And of course, this is the same as 2 minus 1 being 1, so it's the same as 1, 0. And now we can draw this translation, f of x plus 1. The turning point will be 0, negative 1. Then the x-intercept of 0, 0 will now be at negative 1, 0. So at negative 1, 0. And we have another intercept at 1, 0. So at 1, 0. So just connecting these points. So the blue graph here will be the graph of f of x plus 1. And we can see that the original graph of f of x has shifted 1 unit to the left. Let's look at the translation f of x minus 1. So in this case, we're subtracting 1 from the x inside the brackets here. Now, this is a horizontal shift of 1 unit to the right. So important to note that when we subtract from the x's inside the brackets here, the shift will be to the right. So let's look at this graph. So the graph of f of x, a parabola. And once again, we can look at a couple of points. So the point P, the turning point, will now be mapped to P prime. And although we have x minus 1 inside the brackets next to the x here, next to the f here, we don't subtract from the x's. Because the shift is to the right, we actually add to the x's. So it's going to be 1 plus 1 here, which is 2. And nothing happens to the y's. Then the point 0, 0 here. So 0, 0 will be mapped to a point. And we know our y's are going to be the same. And once again, we don't subtract from the x's. We actually add. So 0 plus 1 will be 1. Then this point here, 2, 0. We add to the x's, so 2 plus 1 will be 3. And then we have 0. So now we can plot the graph of f of x minus 1. The turning point is 2, negative 1. 2, negative 1. Then we have 1, 0. And we have 3, 0. So just connecting these points. And the blue graph here is a graph of f of x minus 1. And we can see that the original graph of f of x has shifted 1 unit to the right. Then we also want to look at a transformation that is known as a reflection in the x-axis. Now, this transformation has the form negative f of x. Remember that f of x refers to the y values. So under this transformation, all our y values will change sign. So if we take any point on this graph, let's say point xy on the graph of f of x, it will be mapped to a point x. So our x's will remain the same, but our y's will change sign. So x, negative y. Let's take a few points on this graph. The turning point P, which has coordinates 1, negative 4. Now, this point will be transformed to P prime. Our x's will remain the same, and our y's will change sign. So 1, 4. Let's take another point like the y-intercept here, which is 0, negative 3. So the y-intercept of 0, negative 3 will be mapped to 0, positive 3, and so forth. So we're able to draw the graph then using these points. Then the turning point of the graph of negative f of x. The turning point will be 1, 4. So 1, 4. And the y-intercept will be 0, 3. Now our x-intercepts won't change because the y-coordinates of our x-intercepts are 0. So it won't change sign. So reflection then in the x-axis. Something like this. We want to look at the last transformation, which is called a reflection in the y-axis. This transformation has the form f of negative x. So under this transformation, all our x's will change sign. We want to use this graph of the function f of x as an example. So if we take any general point on this graph, let's say xy, then this point will be mapped to the point negative x, y. Let's apply this transformation to the graph. We can start with the turning point P. So P1, negative 4. This point will be mapped to p prime, and our x will change sign. So p prime -1, -4. So the y's will remain the same. We can go to the next point here, the y-intercept, which is 0, -3. Now, -0 is the same as 0. So this point won't undergo any change. Let's take the x-intercept here of -1, 0. This will be mapped to +1, 0. Then the point 3, 0, this intercept here, 3, 0, will be mapped to -3, 0. Now we can use these points to draw the graph of f of -x. So we can plot these points. So the turning point is -1, -4. Then we have 0, -3. We have 1, 0. And we have -3, 0. And we can just connect these points. So the blue graph here will be the graph of f of -x. And as you can see, the blue graph here is a reflection of the red one, the original one, which is f of x, in the y-axis. So a reflection in the y-axis. So let's look at your answers to this question. It says describe each of the transformations below. So these transformations. Then it also says if Q is a transformation of the point P with these coordinates, give the coordinates of Q for each of these transformations. So let's look at the first one. It's f of -x. Now this is a reflection in the y-axis. So all our x's will change sign. Now P has an x-coordinate of -2. So that means that Q will have an x-coordinate of +2. So the coordinates of Q then will be 2, 3. Let's look at number 2. Here we have f of x -2. Now this is a horizontal shift of 2 units to the right. Note that even though it says x -2, we have to add 2 units to the x's. So that means that we have to add 2 to -2 here. So -2 plus 2 will be 0. And that means that Q will have coordinates 0, 3. Let's look at number 3. Here we have negative fx or f of x. And we know that this is a reflection in the x-axis. So all our y's will change sign. And that means that Q will have a y-coordinate of -3. So then the coordinates of Q, but firstly, it's a reflection in the x-axis. And then the coordinates of Q will be -2, -3. Then number 4, we have f of x plus 2. So this is a vertical shift of 2 units up. So a vertical shift of 2 units up. And that means that we must add 2 to all our y's. So then the y-coordinate of P is 3. So if we add 2 to it, it will be 5. And that means that the coordinates of Q, in this case, will be -2, 5.